All right, question 4. Graph each pair of lines. Find the slope of each line. Use slopes to determine whether lines are parallel, perpendicular, or neither. So before we get to graphing them and actually answering the questions here, let's talk about how we will know if lines are parallel, perpendicular, or neither. First thing that I want to say is super important is that after you graph these lines, you can't just look at it and be like, oh yeah, those look parallel, or yeah, I think those are perpendicular. They look like they're making a right angle. Remember, you have to know. You can't just be looking at something and make that assumption. So we are going to know that lines are parallel based on if the slopes are equal. And this one's pretty easy. So if one has a slope of 5 and the other one has a slope of 5, they're going to be parallel. Perpendicular, we're going to know that those lines are perpendicular if their slopes are what we call opposite reciprocals. And I would probably write this in your notes somewhere so that you have it. Opposite reciprocals. And what we mean by that is if one of the slopes is 2/3, then a slope that is perpendicular to that, or a line that is perpendicular to that, has a slope that is opposite. So since 2/3 is positive, this slope is going to be negative. And by reciprocal, we mean flipping the fraction. So 3/2. So because they're opposite, one's positive, one's negative, and the fractions are flipped. Just be careful with that real quick. Also that if you have lines that are, let's say, m equals 1/3, then the reciprocal of that is just going to be 3/1, which is also m equals 3. So remember, numbers that don't have a fraction, they're actually that number over 1. And in order for it to be perpendicular, one of them has to be negative as well. So a 1/3 and a -3 are going to be opposite reciprocal slopes. All right, so since we know that, let's go and solve the questions. So we've got point H, which is 3, 2, right there. And we have point J, which is 4, 1. Right, so H and J. And we can draw that line as best as possible. All right, there is my line HJ. And let's find the slope of that real quick. So there's my slope box. So H is going to be 3, 2. J is 4, 1. So I can see that my change of y is going to be -1. I'm going to go down 1 to get from 2 to 1, subtract 1. And my change of x to get from 3 to 4, I'm going to add 1. So my slope of that is going to be a -1. Remember, 1/1 is just 1. So my slope is -1. All right, let's look at K and M. So K is going to be -2, -4. And M is going to be -1, -5. So we have our K, we have our M. And I can draw that line. So we've got that line. We can make our slope box. Got -2, -4. That's our coordinates of K. And then M is going to be -1, -5. Okay, so we've got to ask ourselves, how do I get from -4 to -5? This one's a little tricky. We're going to be going down 1, subtracting 1. Right, so if we're -4 and we subtract 1 more, we'll get to -5. And to get from -2 to -1, we're going to increase 1. Increase 1. So my slope is going to be, my change of y is going to be -1. My change of x is going to be +1. So then this is going to have a slope of -1. So then since my slopes are the same, I know that these lines are going to be parallel. Okay, so remember if slopes are equal, then we know that they are parallel. All right, go ahead and attempt that number 15 with lines LM and lines NP. Go ahead and plot those points, find the slopes, graph the lines, and see if you can figure out if they are parallel, perpendicular, or neither. Go ahead and pause the video, come back when you're ready. All right, so let's take a look at what we have. So I've got my points L and M. We'll start with the blue, though that's going to be this line right here. And when I plot those points, make my slope box, I've got coordinates of L is -2 and 2, and the coordinates of M are 2 and 5. So then how do I go from 2 to 5? Well, I'm going to be adding 3 to that. And how do I go from -2 all the way to 2? That would be adding 4. So my slope is going to be my rise, or my change of y, which is 3, over my run, which is 4. So +3 over +4, which would just be 3/4. So the slope of that line is going to be 3/4. Take a look at the red line. I've got coordinate n right here at 0, 2, and I've got p at 3, -2. I can put those in my slope box for n right here, 0, 2, and p, which is 3, -2. So how do I get from 2 and I go down to a -2? I'm going to subtract 4 from that. And then how do I go from 0 all the way up to 3? I add 3. So my slope, -4 over +3, which then is -4/3. So I've got a slope of 3/4. I have a slope of -4/3. And because one of those is positive, one of those is negative, then I know that they are opposite. And I also can see that the reciprocals, I've got 3 on top, 4 on the bottom, and that switches to 4 on top, 3 on the bottom. So I do have opposite reciprocals as my slopes, and I know that those lines are going to be perpendicular then because of that reason. All right, so go ahead and try that last one, number 16. See if you can figure out if those are going to be parallel, perpendicular, or neither. Once again, go ahead and pause the video and come back to check your work. All right, so taking a quick look at this one, we've got Q, which is going to be 6, 1. We have R, which is going to be -2, 4. So 6, 1, -2, 4. We're going to add 3 to get to 4. And if we start at 6, we're going to subtract 8 to get to -2. So my slope is +3 over -8, which would be -3/8. Looking at S and T, we've got S right here at 5, 3. And then we've got T at -3, -1. Put them in our table, 5, 3, and then -3, -1. So to get from 3 to -1, we've got -4. We subtract 4. And to go from 5 all the way down to -3, we're going to subtract 8. So here I see that my slope is going to be a -4 over -8, which is going to be +4/8. And I know typically we would never want to leave our answer as 4/8. We would much rather change it to something like reduce that fraction. 4 divided by 4 is 1. 8 divided by 4 is 2. So get a fraction of 1/2. But let's make sure that we know what's important in this one. So for my slope, I would definitely want to say my slope is 1/2. But let's make sure that we can take a look at opposite reciprocal. So I do see that we do have opposites here because I have a -3/8 there and a positive, we'll do it right there, +4/8. But we don't have reciprocals and our numbers aren't quite the same. So because the reciprocal part isn't true, I can't say that these are perpendicular, and I can say that these are neither. Make sure you don't make assumptions. I know this one you might have been able to tell that this was not a right angle, but sometimes it might be hard to just look at the graph and know that. So make sure you know when you're looking at it, and that you've shown the work to prove it. And the very last thing on this page is question number 5. We want to fill in that missing information. So remember, a slope of any line parallel to it is going to be the same. So if my line has a slope of 4, then a parallel line will also have a slope of 4. That's going to be the same. And if it's perpendicular, it's going to be opposite reciprocals. So I see that this 4 is going to be positive. So if it's opposite reciprocals, then this one has to be negative. And then also we need to flip the fraction. And just a reminder that 4 is the same thing as 4 over 1. So then if I flip that fraction over, we'll get 1 over 4. Perfect. And then negative 5, let's do that one real quick. So if it's going to be parallel, then they are going to have the same slope. So negative 5, it'll be the same number. And then the slope of anything perpendicular to it will be opposite reciprocals. So since this is a negative number, this one's going to be positive. And then we want to flip that fraction. And just like 4 over 1, this is going to be 5 over 1. We flip that fraction, and we get 1 over 5. All right, pause the video. Go ahead and see if you can complete the other 4 rows of this table. All right, here are your answers. So we've got for the first one, remember, your slopes are going to be the same. So this column of the table should be really easy. It should match this perfectly. So we've got 0 and 0, that matches up, negative 1, negative 4 sevenths, negative 4 sevenths, and 1/3, 1/3. The parallel line is the easy line. The perpendicular one's a little bit tough. So for this one, remember, if we want to do the opposite reciprocal, since this number is positive, this number has to be negative. And when I flip the fraction 1 over 3, I get 3 over 1, which is just 3, so negative 3. 4 sevenths, flipping that, we get a 7 over 4. And then if this is negative, then this answer has to be positive. And the two tricky ones are here at the bottom of the table. So negative 1, first of all, is a negative number, so the opposite is going to be a positive number. And then remember, 1 is the same thing as 1 over 1. So when I flip that fraction, it looks like 1 over 1, which is just 1. So that's not going to have, it does flip, but it's not going to look necessarily like it did, which is why our answer for this one is just a positive 1, because 1 over 1 is the same thing as 1. And the last one is 0. So once again, parallel is easy. If this is a 0 slope, then this is a 0 slope too. So remember, what type of line has a slope that is parallel, or that has a 0 slope? And that is going to be your perfectly horizontal line. So then if I wanted to come up with something perpendicular, that must mean that it's perfectly vertical. And remember, perfectly vertical line has a slope of no slope, or does not have a slope. So something like undefined, no slope, or something like that fits perfect in that box. All right, hopefully that was not too difficult. Notice that we still have one more page of 3.4 to 3.6 that we'll get to later. But for right now, hopefully you understood this, and hopefully those videos help you out.